Hello everybody, welcome to ISRO. Thank you for joining live in this program, and I am very happy to connect with you through this program to answer the questions from especially students and the public related to space programs, specifically the Indian space program, our plans which are already announced, and a lot of interesting topics. I think the students are very interested to ask and then find out related to the space, the technology, the exploration, the science, and very interesting facts that you may like to know about our work in ISRO. And of course, I know there are many people who are interested to know about the possibilities in space sector, the opening of the space sector, the possibility it offers to entrepreneurs, startups, innovators. And many students are interested to know how to join ISRO or work in space sector and how to contribute to this movement. Generally public, those who have a little older, they are interested to know about type of accomplishments and what the nation in terms of its vision in space sector. There are many things I think all of you are interested to know. Possibly you are discussing amongst you, you are discussing with people who knows the topic. And there are many forums where such discussions do take place. I am really happy today. We have started a program, Ask Somanath ISRO. Through this gateway, I would like to connect with you people, specifically students who are aspiring to work in the domain of science, technology, engineering, mathematics, and also would like to have some interest and flair to know about the technology elements that are there in the space and how this becomes useful to the common good of all of us, and have an aspiration to become somebody as a space scientist. And for all of you, I am there to answer your questions, queries, and to possible way as much as I know. And if I am not able to answer those questions, I will definitely come back and refer to and then come with answers next time. But today for the inaugural program, I have received through our team almost 450 questions, and you know that all of them cannot be answered, and those questions have come from different strata of the society, different age groups. Just to tell you one statistics, some questions have come from a 6-year-old child to a very young person who is at 74 years age. I think I want to thank each one of you for taking time to come and ask those questions. I thought that we cannot ask, since I cannot answer all the questions, I should select some questions which come in some certain groups and types, and if I answer some of them, I think many of the questions will be answered. So let me start the question answer session without any further introduction. And many of the children, especially in schools in 10th and up to 12th standard, they are all interested to become a space scientist. And here we have Mr. Samurai Krishnan. He is asking a question. His actual name is Krishna Gupta, I believe. I think he is asking a question that he is studying in 12th standard. I want to know how to become a space scientist and at ISRO, and what should be the pathway to my journey to if we ever come to and sit in front of an interview board that is selecting him. So Mr. Krishnan, I would like to tell you that the path to space science and technology is only through your academic excellence. Whichever domain that you are studying, learning today, you become a top-notch person in that area, putting your best effort. In ISRO, we take people in various skill sets. We take engineers, scientists, technicians, and every domain that we have engineering graduates from electronics background, computer science background. We have people from mechanical engineering, civil engineering, electrical engineering, production, chemical engineering. Then we have scientists who graduate in science, in physics, in chemistry, mathematics, and computer science. Of course, there are people who come through that route. We also have people who have graduation, post-graduation, doctoral degrees in the domain of space science, atmospheric sciences, and other physical sciences, including botany with specialization, forestry, in agriculture, people having background in ocean sciences, climate and weather related area domains, geology, water engineering. and sustainable engineering domains. I think all these domains that we take people in ISRO. So if you are keen to join ISRO, I must tell you the easiest way or the fastest way is to be through an engineering route, because the number of employable candidates are more in engineering domains. But other domains, if you are interested to take, I think if you really become a very top-notch person in, say for example, physics, with this good academic credentials and with a postgraduate degree, and if you have a postdoctoral degree, still better. Otherwise, you can even join some of our labs to take a research activity and then leading to a PhD also. So there are different domains possible. And for engineering graduates, we conduct a national test every year, and this national test you will have to write, and then if you get through the test with good grades, with sufficient number of backups, we will call for interview. And I am sure that one day you will come and sit in the interview board and listen to those questions, and if you do very well in the interview, you will be picked up for the job. So let me tell you, the first thing today, as a school student, the best thing that you can do is to make very good academic credentials in terms of the grades, and also your skill set to write the examination after whichever course that you are going to do after the 12th. All the very best to you. So let me go to the next question. Here again, Mr. Santosh of class 11 asked the same question: how do I get a job and to get into ISRO and become a rocket scientist? Is ICRB examination is tough? Of course, it's a tough examination, because for every 100 vacancies that we have, the type of applicants that are applying for the job is almost 1.5 lakhs. There is so much of interest. I think it's going to increase only. So it's going to be a tough examination. But they are fundamental questions that we are asking if you are going to write this examination after engineering graduation. And if you want to become a rocket scientist, of course, the best thing is to become an engineering graduate and join in whichever domain. I would like to go further on some interesting questions about stardust. I think the question is asked by the name of the person is not very visible, but then the question is on the astrobiology domain. What we can expect from ISRO in the field of astrobiology? Will India initiate research about it in ISRO soon? Of course, there are a few number of scientists who are working in this domain in our science laboratory, especially in the domain of space physics, as well as in the lab that we have at Ahmedabad, the Physical Research Laboratory. They look at astrobiology in different areas, how life form actually got created on Earth, what type of meteorite action or impact that could synthesize complex molecules. And they do similar experiments in lab and then try to derive certain conclusions out of it. They also do a lot of such samples evaluation which comes through the meteors samples that they are collected all across the globe, are analyzed to find out the type of understanding that we have. Of course, this is going to work, expand further with more and more interest happening in planets as well as exoplanets, etc. Mr. Ganesh Iyer, his name is Ganesh Iyer, but his name is Ganapati. He is doing diploma in EEE and final year. So he would like to know that whether ISRO would come up with special programs to allow common people or students to get a chance to travel into space, just like the other countries are doing. When you talk about travel to space, I mean that you have to become an astronaut, of course, without being an astronaut trained to handle such difficult tasks, that you will never be able to. Our space vehicles still not become like cars or buses or aeroplanes, where a normal person without any skill sets can board it and then take a travel. It's not going to be. Even if you are talking about a travel to Mars, you understand that it is going to be a long journey with a lot of capability, physical capability to handle the launch related issues as well as risks in that mission. I believe that with the increased human access to space in the coming days, currently the typical vehicle that take human beings to space, we have at least typically 4 people, 5 people, 6, 7 people. In space shuttle they were up to 7. In the current crewed crafts there are typically 4 seats, the maximum. Maybe in some of the future vehicles will have more. So these are the type of people that are traveling, and all of them wear space suits and sit in very confined environment to handle the very high acceleration that is generated to do launches, and also the post-launch issues that will happen due to radiation, the vacuum effects, etc. and you need to train to handle such situations, because everything is not going to be like a airplane travel. Airplane travel also evolved over many years to the current level of normal people getting in and getting out without knowing the complexities that are involved in a typical aircraft to make its flight safe for you. Similarly, I believe that one day the space flight also will be like that. People will be able to board and handle all of these critical issues much easily. But until then, you have to go through a training program if you want to fly in space. There are space tourism opportunities where you need to train very little. But if you want to have an operational space flight, you need to undergo severe training. There is another question from a friend which name is not very clear. His question is, what works ISRO is doing towards addressing climate change, and how can I contribute to this great thing? Of course, climate change is a very real thing. All of you know that especially the climate change induced by human activity on Earth is something that we are discussing. Climate change, of course, happened due to natural reasons, which you cannot do much on about it. But the time cycle involved in climate change in a natural way is much longer, and life forms normally adapt to it, and if you cannot adapt to it, you end up losing your whole species. But the man-made climate change is something which you must all be worried about, and this is happening much faster than you ever thought about, and that's why it is important. And for climate change, what the space can do is to do measurements of various parameters, especially the essential climate variables, which helps you in modeling the climate and weather. And if these parameters are able to be monitored in a continuous manner from space-based instruments, you can allow scientists to make modeling, make long-term predictions, and bring it to our notice that what are the sources of this climate change. You can find out the interconnection between so many of these variables and the real physical feeling, like temperature rise, which is happening, the El Nino effects, the global warming, which you are all aware of, and also the greenhouse gas emissions, which is one of the reasons that you talk about, is a reason for the global warming, and many other parameters. Of course, extreme weather situations, the melting of the glaciers and the polar ice and rise of the sea level. I think all of this are the result of the climate change. So the space can help you to monitor it very effectively. Out of the 50 and plus essential climate variables, at least 23 of them can be monitored using the space-based observations. In India, we are using our satellite to monitor 12 to 13 such essential climate variables. It includes the cloud, the precipitation, the rain, the aerosols, the sea surface temperature, the sea waves, the sea color, and earth-related reflecting characteristics of the surface, etc. And all of these are supplied to the modelers who look at this climate change. And now coming back to your question, how I can contribute. I must tell you that each one of us, you can contribute in this effort of climate change. And what we are discussing, climate change is essentially the man-made, human-made impact on climate. So you become a torchbearer of this movement. You can work with your society, you work with your friendships on advising them what all things you should do and what all things you should not do. I think enough of material is available on this topic, because this being a space topic, I am not going to discuss that. How to minimize global warming, and how do you work with respect to saving energy, recycling materials, using sustainable approaches to make greener earth. I think all of this you can do as a person. I have a question from Satyam Siddharth. He is a student of 11th standard biology science stream. I have heard that astronauts for the Gaganyaan mission are from Indian Air Force, but are there any chance for the astronauts from ISRO will select in future that can be from bio stream as well? Okay, so you are interested being a student of biology. You think that you cannot become an astronaut unless there are some bio stream people are selected. I believe that there are different ways of getting into an astronaut pool, if at all we have an astronaut pool of big number that we will be able to take in the future. Today our program called Gaganyaan, we have the first set of astronauts who are coming from Air Force pilots, and there are no other way, and they are trainers of the pilots, and they have the type of skill sets to handle the early part of this mission, especially when it is under development. They have to help us undergoing the training and also help us to develop the Gaganyaan project itself, including the engineering of it. So they become very, very important in that aspect. But future astronauts will definitely be from many other skill sets. Some of them could be engineers, some of them could be bioscientists, some of them could be doctors, and some of them could be even a person in the literary background. Why not? The only thing that we need to do is you need to go to space to do some activity, and it depends on the activity that we will be selecting people. You know that we are going to build a space station called Bharati Antarisha Station, and we have a goal to launch it by 2035 and to have human access to it. And when you have space station, there will be hundreds of experiments happening in the space station in different domains. It could be from material science, it could be from drug discovery or bio-related experiments. So if you are going to be a bio student, and if you are interested in molecular biology, in medical synthesis, or in plant related or genomic studies, possibly you have an option to go and do research in the zero gravity effect of each of these synthesis, and would like to do an experiment in space. Maybe you will become an astronaut that you will travel one day to space and work on it. But immediately that what you need to concentrate is to find out the type of domain that are possible, how to connect it to the space, whatever work that you will do in the future. The space means there are many things that you need to connect. One, of course, I mentioned is the zero gravity effect. There are other effects like the radiation effects, the vacuum effects, and if you are interested to find out how these affect mutations or gene changes or in medical molecular synthesis, etc., possibly this could become a research topic and you will become an astronaut who can work in that domain. I have a question from Mr. Sumit Patacharji. He asked the question, please start a project for space cleaning of debris, a vehicle that can go around and collect debris to bring back Earth. This is his question. Oh, so it's only a suggestion, it's not a question. Fine, I think your suggestion is well taken. I think all of us want a vehicle that will go to space and collect all the debris, like it will sweep in a river, remove all the debris or pollutants, plastics, etc., that you can spread a net and then collect them and bring back. I think it would have been a great idea to do that. But unfortunately, the space is not like that easy. Because when the plastics are floating in water, they are all at the speed of the water that is moving. Whereas in space, they are not moving in a synchronized manner. In space, each object travels at tremendous velocities in different directions. The typical velocities range from 8 kilometers to 20 kilometers per second. And this travel at extremely different directions, and directions won't even be parallel to each other. So if you have to catch something in that velocity, the only way is you should also reach the same velocity, in the same orientation, in the same direction, even if a small angular error that you will diverge or you will collide with it. So, and once you have reached that exactly the velocity, you can connect with it, then use an engine to reduce its speed and bring it back to Earth. And you can do it only one item at a time. And after that, you have to change the position to another object which is moving in another direction, another angle and another velocity. And this requires so much of energy, of propellant. So a net that is spread out in space cannot capture all the debris. It's not practically feasible. But a lot of ideas are coming. I am not telling that it is impossible. There could be possibilities. But today what we must look at it, how in front of debris, is that how do we really minimize debris and bring about more sustainable space access? This is a bigger question. We should not cause collisions in space satellites. We should not cause them to explode. And we should control the re-entry of non-functional satellites back to Earth must be done. These are the things that we can do. Of course, observability of this debris is also a big challenge. Anything bigger than 10 centimeter only currently we can observe using radars. But we must create radars which can see very, very tiny things, at least to protect our satellites and missions from the debris collisions. These are the things that we can do at this moment. Okay, let me move on further, and I have again back to the joining ISRO. There are a lot of people interested to join ISRO and work in space sector. So Kiran Shetty asks, what are the skills and qualities that ISRO looks for a potential employee, and what are the different career paths available within the organization? After you have joined, you want to know. And of course, skills and qualities. One of the important quality that we are looking at, or the skill that we are looking at, is academic excellence. Of course, in whichever domain that you are working, studying, and planning to join, we need to have people who are really at the best. So we would like to look for that quality. Second is, of course, you need to have a ability to work with a team. Individual excellence is very, very important as a student, as a researcher. But once that you have that skill, and after joining ISRO, if you do not know how to work with team members and how to deliver things working with others, one thing we know each other in ISRO very well is that individual skills and excellence cannot always produce results. And for doing a project that you need so much of support from his colleagues, your co-workers, and you need to extract that. For that you need to have a teamwork mind attitude. This is again very, very important. And once you are inside, there are many career paths possible leading up to different positions in the organization as allowed by the government of India in their promotional policy, and you can take different tasks. If you are a technical person, you can become project directors, you can become center directors, and of course can become chairman of ISRO as well. But if you are into administrative domains, there are different career paths for them. And if a technical hands, and for them there is a different career path. And I want to tell you, in ISRO we make sure that there is no stagnation as much as possible, and always there are challenging opportunities always thrown in front of people. So this is something which I would like to tell you at this moment. Possibly you will not even understand what exactly is waiting for you until you join ISRO. So let me welcome you. So here again another question comes from Yash. He says, what advice you will give to students like me who are passionate about pursuing a career in space research or engineering, and how can we best prepare ourselves for the challenges and opportunities in this field? Here I want to tell you that the opportunity is not only in ISRO. The whole space sector of India is now opening up. I think this is something that all of young people must be realizing now. ISRO has a certain staff strength, and you cannot recruit people beyond that sanctioned staff strength. And every year we recruit, of course, and this is good number. But what you offer from outside in startups and industries in working in space sector? And you will wonder that today we have industries who are contributing to space sector in system design, manufacturing, assembly, testing and delivery. Thousands of people are working in so many sectors. In public sector undertakings, in private companies, startups, at least 500 companies are contributing to space sector in various ways. But the most important thing that has happened in the recent times is the emergence of space-based startups. Almost 200 startups have registered and they are working. At least a significant number of them are scaling up their work. They are recruiting scientists and engineers in their domain in various areas. Some of them are designing rockets, some of them are designing satellites and building them. Some companies have already built their satellite and launched, and they need people like in ISRO to work for them. And there are some companies who are working in the sectors like applications, for example, communication, remote sensing, image processing, which will lead to commercial applications and things like that. So all these opportunities are now slowly developing in India, and if you are a right skilled person in space sector, there is huge amount of opportunity in many areas. For example, if you look at engineering domain, in every domain, including even material science to manufacturing, you have the capability. In the application side, communication, imaging, strategic and image analysis, artificial intelligence, software development, electronics, I think all these areas are open to people in the core of technology to work in space sector. Okay, Mr. Deba Pratim asks, he heard a news that 6 months ago, Arianespace signed an MOU with NSIL regarding a use of LVM-3 rocket and Ariane 6 rocket to address global launch services market needs. He didn't understand what exactly this message is, and he would like to understand what exactly this meaning of this statement. So I want to tell you, the launch vehicle market or the launch services market in the world are not available in plenty. It's a very highly costly business, because every launch typically cost of a rocket. It can be very high depending upon the market demand. Now, if you look at world over, there are rockets in US, there are rockets in Russia, China and India, and Japan also now, which can be used for commercial purposes, and Japan still not started using it largely for commercial purpose. And if you look at the Europe, then you will find that the Ariane rocket, which was Ariane 5 rocket, has now retired, and Ariane 6 rocket, which is yet to take its replace, it has still not become operational. So there is a huge demand for launches, especially from various countries in Europe and America and South America, Africa, etc., and Southeast Asia. And for them, either they have to come to Ariane 6 or they can come to LVM-3, or they have to go to America or Russia and China. And because of the geopolitical situation, there are different situations in which somebody would like to prefer to travel in very safe rockets. So the safe rockets generally we know LVM-3 is a very safe rocket, geopolitically not involved, and you know Europe, Ariane 6 is also like that, it's a commercial operator. So we thought that why not we join together to create a good condition for users in space sector. If you register as a demand in Ariane 6, and if Ariane 6 is not able to launch, they can assign the launch to LVM-3 and vice versa. So this gives both operators a comfortable situation in handling contracts, and this is precisely the role of that signing of an MOU by NSIL, that it will showcase our rocket LVM-3 in a greater confidence to the general customers, that who would like to travel in Ariane will also have the same level of confidence to come and travel in LVM-3. That's why it is very important. Okay, again Abhishek Raj asks, I have just passed out of 10th standard, still trying to figure out which stream to take. Is there a scope for astrobiology in future? I think you have already heard what I spoke about. You have to only make up your mind. I would like to tell you, the passions are very important. Your likes of the subject is important. If you want to work in astrobiology, then be very, very specific. You need to take the topics which will help you to skill in that area. So ask with some experts to understand what is available near you, which all courses that you should take, and to become astrobiology scientist in the future. Mr. Ramjit RK asked this question, when we will get the access in Navic app, or when will it come in the Play Store for usage? You should understand that Navic is not going to be an app. See, for example, you know GPS. GPS is not an app. GPS is a service that is available which will run many applications. So it is behind the applications. What essentially GPS does is it provides positioning services. So it gives you some signal to your device. Using the application, you can identify the position of the device. That is precisely the GPS does. Exactly that thing Navic does. So now coming to Navic. The Navic is also exactly like the GPS type of signal, but it's different in its arrangement. The Navic is based on a stationary set of satellites. It's called geostationary satellites are providing Navic services, whereas GPS is provided by orbiting satellites around Earth in large numbers. So they are MEO satellites. Now, when you have geo satellites and it is a regional navigation system, it is available only in India and its environment, maybe 1500 kilometers beyond its area. And this data has to be used by the applications. For example, if you have a map services. In the map services, when you want to use a Navic or Google, GPS type based services, they have to tie up each other. The software has to understand that signal and trigger it to access the data from that and then use it in the app. So this is something that we are trying to do. We connect with the various app makers and app deliverers who are working in the mapping regime, and it could be in mapping, it could be in transport services, it could be in various other geolocating services. So to them, Navic will speak and will arrange so that this will be made available. It's already there. I want to tell you that Navic services has already come into some of the map based services which is there in automotive sector, and some of the cars who are made in India has in place of Google Maps, there are other map services which are coming from Map My India is a company which is actually selling such mapping services for use in cars and automobiles, and for them we have integrated the Navic based geolocating services into it. So it can be used like that, and we hope that our Navic will become more civilian user friendly. Currently we have only 5 satellites functioning in this. We need 7 satellites to be functioning fully operational, and we also have to have a frequency called L1 frequency to be launched, and that we just started with the launch of 1 satellites and another 5 more satellites to be launched, and we believe that the entire civilian sector to use this fullest complement of satellites will happen in another 2 years of time. Okay. So let me go to the next question from Namman Praveen Shinde. So he asked a very futuristic question. There are assumptions that the Earth would no longer be a better place to live. Could you please explain the ideology of space colonization planning by ISRO? So you are assuming that we will not be in a position to live on Earth, hence we should migrate. Of course, there are threats on our ecosystem because the Earth is a very fragile ecosystem, and you all know that the Earth is in such a condition, it's such a delicate balance of temperature, the constituents of particles in the air, even the radiation, the ozone, the position, the temperature conditions, the water vapor, everything is in such an exact balance. The energy balance in the system, the elemental balance in the system is so perfect that we, a human being and other life forms can live here safely. But if you continuously erode this and cause very rapid change in this, it can become inhabitable. But we should not look for another place to live only because we want to make Earth to be inhabitable, then move. I think that's not a good idea, because the places that you are looking for to move are equally uninhabitable than Earth right now. So you have to make it habitable, then only you can go. So there are other dangers associated with the Earth even today. For example, an asteroid can come and hit us, which will create the same situation as long back when Earth became an inhabitable place and many species died. All of you know that situation. So similar situation can happen to Earth. There can be a pandemic which will erase most of the life forms from here, or there can be a war, which of course should not happen, that will create threat situations, that radiation can become a very important critical issue for all of us to live. So all these are possibilities. I am not telling that all these are going to happen, but most important is, as human beings, we are explorers, and we must travel and find out where all we can go. Like people from the Europe went to find out America. We have to, since you have a tool to travel beyond Earth today, the rockets, we should have a method to travel to exosolar planets and find out where there will be a possibility of human life to establish. I think we should do that, irrespective of the fact that Earth is becoming inhabitable or otherwise. So we should continue to do the steps of work, and I can tell you that it's not going to happen next few years. It's going to take years together, and we are at the beginning of this space journey. We just built some rockets and started traveling to moon, and we have to travel to Mars. We have to travel beyond solar system. We must find how to handle long-term years together, hundreds of years of space travel. How to do that? I think all these technologies will develop in the due course. Today in ISRO, we are trying to build the first step capability. How to step out of your home first with the required safety. From our dear home, we should go to space and then come back. And once you do that, master it, my next generation will master how to go to moon or to Mars, and how to go to planets, and how to find ways to go to exosolar planets. Until then, let us do our work today. And the current work is that one stepping stone for the future human space travel. Now, the same person, I think he is asking a question or maybe a suggestion. ISRO is famous for its long-term vision. Each and every mission has lots of time duration collecting information, sending to the research center. What are the future path, breaking and historical event plans in ISRO which anyone had not achieved? Okay, all of us are interested to know something that nobody has achieved. Of course, it's something very difficult to see and envision, which nobody knows yet. But all of us know something, that ISRO has an ability, India has an ability to do this space sector, work it very well, and our ability generally in terms of frugal engineering and very low cost engineering. There is so much we need to yet to catch up with the rest of the people in the world. For example, in the domain of human space flight, we have not even reached that level. We have not gone to moon and landed on the moon. Americans and Russia has already gone and landed on the moon. We have not yet built a space station till now. I think we have to do that. And we know why it is important for us in the future to support the research domain in the microgravity and also to bring out economic benefits. And we know why we should go and land on the moon and create our own share of activity on the moon economy. I think all of this we know. We need to do all of that first. First, you must become equal to others. Then we will try to do something fantastic. But don't have to wait till then. We can always do some better way of doing things. And that we continue to do. For example, Chandrayaan 3 is a classic example of, though we have not gone to moon and landed ever, but we have landed this time with a lot of world competition was going on. We were able to land on the moon very safely, soft land it. I think it's a great achievement for all of us. We must all be proud of that achievement. There are many more things that we need to do on the ground reach up to the sky. For example, we need to find a sustained space program itself, which will run on its own. For example, we want to scale up the space activity in economics of the space activity so that it sustains by itself. We must to create a business around the space activity so that private and partnership will come in space sector, so that there is an economic drive to make it grow. Otherwise, it will not grow, it will not sustain. Because in US, when the earlier moon program died after 1960s, 70s program, nobody took it up because there was no economic reason for doing it. Today, it is different situation. So we must find the reason for it. Then third, of course, is the strategic reasons. As a nation who is envisioning to become a powerful nation, we cannot afford to be left behind in this greater technology. So all of these are important for us, and we are trying to work out a vision for us. It's already been announced by our Honorable Prime Minister. Possibly you already know his speeches. You would have heard about talking about our exploration to moon, to bring back sample. He told, and he said that we should go to Mars and Venus. We should also establish our space station, and we should also land on the moon one day. 2040 is the deadline that is given to us. So we are all working in this road towards that. But this is all certain high level goals. But there is so much of technology development that has to happen. All of this finally has to lead to. I think we are working on all of those core elements of technology which will make us to achieve these goals one day. Mr. MGR asked a question. I think it is slightly a confusing question. Is there any process of launching satellites and how final assessment is done for launch? Process. I think you may be interested to know how do we give clearance for a launch to go safely. When everything is ready for launch, how do we say, yes, now you can go? Somebody presses a button, yes, it's a go. You would have seen in movie. So we also do some press button, key, etc. But the decision is not made at the pressing of the button. The decision is made over many months of hard work. It's a systematic work. It's not done by one person. On the day of the launch, yes, it is ready for going. The decision to that is a continuous process of many people looking at every element of the rocket. Somebody who does a small control package, somebody who manufactures a part, somebody who integrates a software, all of them go through a systematic evaluation. Then at the end of it, he says it is certified. And this collection of these certificates of 100 and thousands of items will come to a next level of evaluation. Sometimes there will be a deviation, and these deviations are discussed threadbare in a committee of people, and they say whether it has an implication or not an implication, and they clear again. So we go through this process of every critical look of every element, nut, bolt, software, code, and process, and then clear it at different layers of the organization. And at final level, it will come to committees like the flight readiness review, mission readiness review, and such forums are there with senior people. They will listen to the overall status, listen to the changes that has been done. They will listen to the type of deviation that occurred and assessment of the different teams. And after hearing all of this, they will conclude that all what you have done is right at this moment, and we can go ahead and give the clearance. And that time, they authorize the concerned executive to do the pressing of the button. So it is a collective wisdom of the experts from multiple domains ultimately lead to the clearance of a rocket or a launch or a satellite, and that's how it is becoming successful, and it is not possible without that collective wisdom. Okay, so that's a skill that we have developed within the organization. Okay, there is another question from Shri. Shri is asking, there is an increasing concern about space debris. What measures ISRO is taking to ensure sustainable and responsible space activities in the long term? So we started a special laboratory called IS4OM, ISRO's Sustainable and Safe Operational Laboratory, operational space. And what we are trying to do in ISRO is to look at all the objects in space that are catalogued and available. And this is available through various observation platforms across the globe, and some of this information is available free, and some are charged and available. And using this data, typically of thousands of satellites and objects that are orbiting around Earth, and we do a computer simulation. Every day this is done. And this computer simulation will tell you how they are moving around the Earth and whether they will come closer to each other, that we call conjunctions. And this closer is few kilometers closer, not exactly meeting each other, and with all its error bands, etc. because every observation has its own uncertainty, hence the prediction also has uncertainty. So when they come very close, like few kilometers, we assess this and then warn the people. It could be our own satellite or it could be somebody else's satellite, and this warning is issued every day. And based on this warning, the satellites will move little bit here and there, so that this warning vanishes in the next cycle of analysis. So this is one activity we are doing. We are also trying to create our own observation platforms like radars, and these radars and optical observatories are important for us. Some of the large telescopes, we can actually see the satellite and see somebody is coming near to it, how it is moving, etc. So this is yet another way of doing it. We are also helping our design teams to create very sustainable operational principles. That is, if a satellite is nearing its end of life, we tell them, yeah, now it has come, time has come, and you should deorbit it like this. And we identify what are the processes required and how to do it. And we have recently deorbited at least 3-4 satellites. Then another method is that we make sure that they are removed of propellants, gases, so that they don't explode like the rocket stages. So all of this we do. So we drive the people from design to operation in every level, so as to make sure the sustainability of space is assured and we don't clutter the space, we don't add more debris. I think it is our word from India, and we have to be an example for the entire world. See, one question Mr. Trinetra is asking, sir, can you please share some insights on the launch capacity augmentation that ISRO is undertook? Yes. In terms of numbers, I think he is interested in the number of launches that is going to take place. I would like to tell you, Trinetra, the number of launches is a function of the demand now. The market demand, basically the satellites are the users. So the users are more, naturally the launches will be more, and the users are less, launches will be lesser. So who are our users? The users are the customers for who dealing with the television broadcasting, therefore communication satellites. Those are dealing with internet services. And second set of users are the ones who using the imaging services, the remote sensing satellites. And the third class is the navigation services, which is again government owned. And the lastly is the scientific missions, which is again done by government. Now, so the users are commercial users, the quasi-government users and government users. And based on these users, we aggregate the requirement and build the satellites. And when satellites are ready, rockets are also made ready. So we make an effort to have this as fast track as possible. But then many of the process of building the satellites and launching them takes long cycle time. As you know, a typical satellite from concept to realization takes minimum of 4 years and maximum can be 8 to 10 years. You know, Aditya satellite, which we launched recently, took 8 years to build, conceive and build. The NISR satellite has almost taken 10 years to conceive and build to this level. And rocket typically takes cycle time of 2 years from material procurement to manufacturing and launching. So it's a long gestation time. What we are trying to do today is to find out more users. So who are the users and how to build more satellites, and naturally the launches also will increase. Today in ISRO we have created a capability that up to 24 to 30 satellite launches are really possible theoretically, but that much are not really happening because of various reasons of demand creation not reached up to that level. And this is something which we are looking at from private, from public, from government, how to create more demand for satellite based applications. In India there is huge potential today and we are making it ready. Even our rocket manufacturing, this many numbers, we have to find out how to do it much faster. Recently you would have heard that we have contracted our PSLV building to private companies to increase the rate of building and launching. And this first rocket will be launched this year, and I believe subsequently they should be in a position to build more frequently and launch more frequently. Similarly, our SSLV has been launched successfully, and we would like to see SSLV taking shape to launch at least 12 to 15 launches in a year itself. So these are some of the goals that we have put. I think it will happen in few years of time. Okay, there is an interesting question. Mr. Bhavya Shah is speak about Gaganyaan program. I think Gaganyaan program is interesting program. He wants to know whether there will be only one Gaganyaan launch or more launches will happen. Now, that's a very, very important question. We ourselves asked whether we want to just launch and show that we can launch a human beings to space and be happy with it, or should we convert that whole possibility into a future. I think it's already, I have already told that we have a long-term plan now for Gaganyaan, that we call it a continued access to space by human beings, Indians. And we are going to have that for various reasons. And finally, we will be building a space station, going to moon, etc. So it's going to be there. And he is interested, what path should one follow to be part of it? Of course, you can be an astronaut, but you can be part of it being in the ground also, being part of the development team, design team, the operational team, support team. I think there are many roles that you can play, or even a scientist who will design a experiment for the astronaut to perform and get the results. So there are different ways of supporting. I said that you can be a part of the ISRO, or you can be part of the industries that will finally make use of such services. So there are different ways. Since as I answered already, I don't want to explain it further. Mr. Talhan Varnasi, he asked a question. How does ISRO plan to leverage public-private partnership to further India's space-faring endeavors? Very interesting question. I think in space sector, nobody would have ever dared to ask this question long back. We would have thought that space is such a secret thing and only government should do, and all information related to that should be kept very secretly. I think all those narratives have changed now. After the space sector reforms happened in 2020 and the space policy of 2023, you know that everybody in India is empowered now to work in space sector, irrespective of the domain. And if a company which is an authorized company who has a rightful interest owned by Indians approaches us to hand over technology of space and make use of the facilities of ISRO to build a new space system, it should be allowed. That's a rule, that's a law now that has been passed. So we should look for people to come and work in space sector. And in private-public partnership, there is something which is very important. It's an economic model of how to build systems. So public comes because the government funding and ISRO is coming. Private comes because there are industries and companies who want to join. Financial institutions can join. And this is something very important, and some models are available. ISRO, we are trying to build this model now for building our future rockets, the NGLV. We are also looking at how the launch vehicle Mark III, which is the biggest rocket, now have to go to industry production. PSLV has already been moved, but LVM3 also has to go. This model, we would like to do it in a public-private partnership model, where the stakeholders like the industries, the users, everybody will come on board. They will take their share of work and do that work and then build the rocket and launch as a company. With the NSIL, New Space India Limited, as at the forefront, the public sector undertaking of the Department of Space, ISRO as a technology provider, and the industries as the funding institutions as well as the responsible shareholders. They will be able to build this rocket and launch. So we already worked out an overall architecture of this, and it will be happening soon. Of course, there is a question from the Seema Garg. She asks that recommend me some best space books related to cosmology or something else which will help me as I am still 15 years old. Teen, okay. And 15 years is a very good age for reading and understanding space. I think you are no longer a very young kid. You can understand much of the space technology and space science and create a right type of interest at this time. So, since this is not a forum which I can talk about books because you will not find it easy to read, what I will do is I will post some list of books with its cover page a little later. So, for different age groups, for school children and they are into the entry to the college, the right type of books that you should be able to read in multiple domains. For example, some of them are very story-like books which will generate the enthusiasm, interest in the subject. Some of them will be specific to the domain. For example, if you want to understand how satellites function, how they are designed, there is one type of book. And if you understand the entire cosmology, the evolution of the universe, and to understand how the latest theories are driving you to understand the universe, but it will not talk about space technology. So there are different types of books which you should read, and as a student I encourage you to read first the one which will generate more interest in you. Then you can go to the technology books later, once you have gathered sufficient interest and you have to choose what you want to do. There are books written by retired ISRO people. There are books written in India itself, sufficiently good ones, including reasonably high-end technology which can be read only after you have reached some engineering level, not at the school level. So I will post it little later and you wait for it. There is a question from Abhijit Das. He says, what is the potential for privatization of space sector? I would like to tell you that the concept of privatization doesn't arise at all. The question is, it should be how is the private participation in space sector. I think this is very important. I think this is already very high. The most of the manufacturing of the space sector, most of the suppliers for it are from the private sector. About 85% of the money that we use for launching is actually spent in the private companies. They are only the one which are value adding this to make the rocket today. But what is more important today for us is to have companies or industries who will be having end-to-end capability. For some companies who want to design a rocket, will there be a rocket tomorrow? Some company wants to design a satellite, will he be able to do it, and on its own capability will it be possible? This is something which we want to ask and then create in this country. We want space companies to come up who have a largest skill sets to handle the demand of the space sector. I think this is happening now with the support of technology collaboration that is happening, and also acquisition that can happen from foreign countries, the foreign direct investment that can flow to this based on the opening up of the space sector. The whole participation of private entities in space activity is going to increase, and this is also going to happen with the possibility of more and more services in space sector which will become economically viable. Both should go together, then only it's going to happen, and we are looking forward to create the right type of environment for them to sustain and survive. Okay, Krishna Swami, he asked a question. He heard about Exposat. I think you are aware of Exposat, and are there any more missions to study for interstellar and intergalactic space? See, there are many things that you need to study in space. Interstellar observations are important, like the one which is done by space-based telescopes, the Hubble, the James Webb telescopes, they look at that. Our Astrosat has been looking in multispectral domain through exactly the same thing. We have done that. Exposat is for a specific purpose. Exposat is looking at the polarimetry of X-ray radiations coming out of black holes and pulsars and twin stars, especially when they are eating into the nearby stars, and the type of X-ray emissions, and you can quantify the mass accretion, mass being pulled through the X-ray polarimetry. So there are specific topics that we want to understand through designing a right type of instrument and launch, and this is the very interesting part of space. Simply putting a camera in space don't give you every observable data, and it is not possible to make an instrument that will see you everything in space. It's not possible. So you have to select what you want to see. We are thinking about many space missions. We are first interested to understand about planets. First thing is about planets, because they are our nearby members. They should know about them. For example, Moon we have been exploring. 3 missions we have done. Mars we have done 1 mission. Now Mars we should go deeper and understand. We have to land on the Mars and conduct some in situ experiments to give us more insight on Mars. We want to go to Venus, and Venus is very interesting planet which has an equal mass like Earth almost, and it has an atmosphere which is almost 100 times denser than atmosphere, with sulfuric acid or acid rains and complex atmospheric constituents. Similar to that, there is a Mars which has a very thin atmosphere, 1/100th of atmosphere. So we don't know what made this atmosphere vanish on Mars, and why it is so thick in Venus, and this must be understood, and we would like to do some specific scientific research to understand this. And of course we will look at black holes. I think as we discussed, we have also looked at Sun. Okay, Sun is again another important member of our solar system, most important member, of course, the energy giver, and we want to look at Sun and look at its coronal mass ejection. Aditya L1 was launched specifically for that purpose in multi-instrument suit that we are observing Sun now. Now again there is another mission thought about, like exosolar planets, that we have to observe the exosolar planets and then make a measurement of the habitability of the planet by looking at the spectroscopy of the atmospheric aspect of the exosolar planet when they move through the front of the planet, and the light that goes through the atmosphere, we can do the spectroscopy and understand the constituents in the atmosphere. This is one topic that currently being discussed, and there are other aeronomy related measurements called Disha, and there are many such scientific missions are in the discussion level. what I want to tell is every scientific discussion is related to the people who are available in the system. After this data comes, we need to understand this data, do research on the data, study it for over a period of time and make some conclusive conclusions. And this is the important aspect. It's not launching them. It is making sense of what you get out of it finally. And once you are able to have such type of people in the system who are researchers and data analysts, then we build the instrument. And also we need to build an instrument which will do the particular function. And once both of this come together, then we should be in a position to plan that mission and do it. And until then we don't do it, because simply launching and getting data is of no use. We don't have people who will be able to make a sense out of the data. So we are working with institutions, research laboratories, or educational institutions, and then find out to create the type of talent pool who will be able to help us to do these missions in the future. Got it? Okay, there is a question asked by, I don't know the name is not clear. The collaboration between HAL, ISRO, NAL for the design and development of hybrid electric propulsion will be used in rockets. Of course, we have been working with various public sector undertakings and labs like HAL, NAL, and many tests are being done, facilities are being utilized for this, for not only for the one you mentioned, but for many things. Our manufacturing, testing of many things, even our rocket design, NAL is an integral part. They do a lot of studies for us to do the aerodynamics, flexible dynamics, they do combustion testing, etc. HAL is a long-term partner in building propellant tanks, structures, etc. So we continue to do that. Okay. There is a question from Samir Gupta. He asked, I think he asked again earlier a question. What does ISRO plan, when does ISRO plan to publish findings of the data of the Aditya L1 and Chandrayaan 3 missions? Yes, this is a very, very difficult question, because the data cannot be published. What you have to find out is what you found out of the data. What is the significant scientific outcome of the data? And data is already coming. I think Chandrayaan 3 data has been collected for 14 days. All the data is with us. Aditya L1 started doing the initial calibration of the instruments, and currently the calibration process is on. Still, data is still coming. And this data goes to the scientist, and they are making some assessment, etc. But you have to collect it over long periods of time and then make systematic assessment of it, then make certain conclusions. I will tell you one example. When Chandrayaan 2 was launched and the discovery of the hydroxyl molecule, the percents of water, it took so much of time, almost 6 months to 1 year or so, because it was not very evident in the very first. But later analysis of the data, after looking at it multiple times and making sense of it, came much later. So this is the nature of the observations. So you have to be very patient enough to have scientific findings come out of it, but data is always accessible for people who are doing it, and it is being made available to everybody. Okay, there is I think the time is up. We have spent almost 1 hour looking at the many of the questions. I think the number of questions are so large. I have selected only a few, even that I couldn't complete. But then I look forward to very interesting topics in the future. Some of them, the type of questions that people are asking, you heard, and I won't be answering most of them if those questions are coming again, because every session that we won't be able to answer the same question and same type of answer. So I would like you to look deeper. Of course, your interest to join ISRO is something very paramount. I think many of you may be still having no clarity on it. They won't know the path. I think that is one issue which you should have a little more clarity on helping you. And many of the conditions, this will come on one-to-one type of interaction only. So looking forward to more questions and more interactions in the coming days. Thank you so much.